Okay, hi all. So in this video I want to show how to convert from a binary number or base 2 number to a decimal number, a base 10 number. So in order to be able to do this though, a little bit of knowledge of indices base 2 is necessary, or like 2 to the power of different numbers. So for instance, you need to know that 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, etc., etc. And just do a few more. 2 to the power of 3 is 8, 2 to the power of 4 is 16. Now, you don't need to, I suppose, be able to convert all of these powers. You just need to be able to use a calculator to be able to calculate what 2 to the power of 5 or 2 to the power of 6 is, depending on the length of your binary number that you're converting. So, and again, I suppose just for those people who are not familiar, 2 to the power of 3 just means 2 multiplied by 2 multiplied by 2. So you have 3 2's being multiplied together. So 2 2's are 4 and 2 4's are 8. You get an answer of 8. Okay, so in order to convert from a binary to a decimal, we'll start with an example, excuse me, of a binary number. So if we take this binary number 1, 0, 1, 0. Now I like to write the digits a bit far apart just so that it's easier to see your workings, I guess, and not get things too muddled up or messy in the middle. So what we do is we, underneath each of these digits, we're going to be multiplying them by something, but instead of multiplying across, because we'll have another digit in the way, we're just going to be multiplying downwards. Okay. Now your powers of 2 here need to be written underneath the multiplication sign here, starting with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, etc. Now you can either write the 2 to the powers or what their actual value is. Either way is fine. I'm going to go with the value for today because I think maybe that's easier to see. So 2 to the power of 0 is 1, 2 to the power of 2, or 2 to the power of 1 rather is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8. So we only needed to go up as far as 2 to the power of 3 for this number because there are only 1, 2, 3, 4 digits. Now, I suppose be careful when doing this. You always start at 2 to the power of 0, not 2 to the power of 1. And you start from the right-hand side instead of the left, going this way. Okay. So next step is we're going to multiply each of the digits in the binary number by each of these powers of 2, and we're going to write our answer down here. I'm going to skip a line and write my answer down here. So 1 times 0 is 0, 2 times 1 is 2, 4 times 0 is 0, 8 times 1 is 8. And then when we've got all our multiplication done, we just add together all the answers that we got. So 8 and 0 is 8, and 2 is 10, and 0 is still just 10. So your answer is the binary number 1010 is equivalent to the, or equal to the decimal number 10. Okay, let's see that one more time. So if we take another example, I'm going to go this time for the binary number, let's see, 11011. Okay, so writing it down, again, we're going to multiply each of these digits by some power of 2. This time I'm just going to write the powers instead of the numbers. 2 to the power of 0, just to remember we're starting at 0. 2 to the power of 1, 2 to the power of 2, power of 3, 2 to the power of 4. And then I'm going to write my answer, skip a line, write my answer down here. So we know 2 to the power of 0 is 1, so it's 1 times 1 is 1. 2 to the power of 1 is 2, so 2 times 1 is 2. 2 to the power of 2 is 4, 4 times 0 is 0. 2 to the power of 3 is 8, so 8 times 1 is 8. And 2 to the power of 4 is 16, so 16 times 1 is 16. When we've got all our multiplication done, we're just adding all our answers together. And of course, we can just leave out zeros for the sake of adding, so it's just going to be 16 and 8 is 24, and 2 is 26, and 1 is 27. So the binary number 10011 is equal to the decimal number 27.